Welcome back, guys. So in today's video, I'm going to be showing you how to make use of dimensionality reduction, making use of the principal component model. So the first one is that I've imported matplotlib as PLT, and I've imported Seaborn as SNS. Then from scikit-learn.decomposition, I've imported PCA, which stands for Principal Component Analysis, which is an algorithm in the scikit-learn package. So I'm going to run this cell. Now, once I run this cell, the next thing is to get my data set. So we are going to be making use of the iris data set, and the iris dataset, I can easily access it from the Seaborn library. So I will just create a variable iris, then equal to, then I will now say SNS, which is an alias. So I imported Seaborn here as an alias. So SNS dot load dataset, then I will pass in iris as an argument here. So let me just go ahead and check the head. So iris.head, which is to check the first 5 rows. Now it's showing me that, so here is the index from 0 to, so this is the first five samples, and these are the features. So you have the sepal length, you have the sepal width, the petal length, the petal width, and the species. So this is kind of a classification problem. So that tends to classify a flower based on these features that are given. So you will see that this actually is a multidimensional data set. So I cannot easily represent this using a 2D representation. So if I want to plot a scatter plot of this now, I can only do it within each feature. So I can do length versus width as regards species. But with one thing about this dimensionality reduction is that it is going to reduce your features, the dimension of your data set, in such a way that it will bring out all the necessary, it will combine the features and bring out the necessary information that is needed. Dimensionality reduction is an example of unsupervised learning. And in unsupervised learning, you do not pass the target rather to the model. So you don't fit the label. Unlike supervised learning, you fit the target to alongside your features to the model. But in this case, you don't fit your model to the target. So all you just fit is the features. So in this case, I am going to be creating my big X, which is the feature matrix, and I am going to be dropping the species column. So in pandas, this is how you do it. So you call the data frame dot drop, then you pass columns in form of a dictionary, in form of a list, and pass the column that you want to drop. So in this case, I am dropping the species. And one thing about this is that the drop function actually returns the other features, then excluding the one you dropped. So when I run x.head, so this is my data frame now. So this is the data frame I will be working with. So the next thing I should do now is to create my model, which is an instance of the PCA. So in this case, this PCA now, principal component analysis, is a class. So then I'll pass an argument, which is n component. Now, this n component is telling me how many dimensions do I want to reduce this data set. So in this case, I just want it to be, I want the features to be in 2 dimensions only for easy readability. So I am taking this data set of 4 features and I am reducing it to 2 dimensions. So Then the next thing I'll do is to fit the model to my data, which is X. Now, once I fit it, as you can see, it has fitted. Then the next thing is to transform the data. So after fitting, you can also fit and transform in one line, but I like fitting and I like transforming. So when I run, watch what will happen when I run model.transform and I'm transforming this. Now you will see that it is giving an array. It is giving an array. So this is a 2 by 2 array. This is a 2 by 2 array. So what I am going to do, remember that we are reducing this into 2 dimensions. So it returned a 2 by 2 array. So what I'm going to do is I am going to assign this into a variable x2, let's say 2D. So I assign this into a variable, and now since this is 2 by 2 array, and the first column actually talks about the first principal component, and the second column talks about the second principal component. So I want to apply some slicing here in order to pick each of them. So I will pick each of them and I am going to assign it back to my original data frame. So this is how you do that. Iris, then I want to, now the first principal component, this is my first principal component. Then from this new array that I have, so I want to grab the whole row. So I am grabbing the whole row. So I am using colon to grab the whole row. So this is indexing in Python. So I am using colon to grab the whole row of the first column. So I am grabbing the whole row of the first column. Then the second thing, iris. Remember that this iris is my data frame. Now x2d. So now I am also grabbing, I want to grab the whole row of the second column. So you know in Python, indexing starts from 0 to whatever. So I will just run this code to keep it in memory. So when I will run my data frame and check just, let's say, the first three. Now, as you can see, new features have been added. New features have been added. So what I will do now is I will use the Seaborn IM plot to actually plot the scatter plot of this component as regards to species. To do that, this is what I would do. So xns dot lm plot. Then the first thing I'll pass is my x coordinate. So my x should be PC1. Then my y should be PC2. Then so my x is PC1, my y is PC2. Then hue is actually, so I am separating these things based on species. So I am categorizing them based on species. So that is why I've put species as my hue. Then the next thing is the data itself. The data itself. So the data itself is iris dataset, and in order not to, I don't want it to fit my regression line, so I will just say false here. Then I'll put my semicolon to suppress some text. Now, when I run the code, I've been able to narrow down the 4 features into 2 features. Now, these 2 features actually describes this data set. So as you can see that there is kind of linearity between, in the case of Virginica and versicolor. So you can see that as PC1 increases, PC2 also increases. So this is how you make use of dimensionality reduction, making use of the principal component analysis algorithm. So make sure you like and subscribe to our channel to be seeing more data science and machine learning videos and tips. Thank you so much.